Hi, this is some exam review from Chapter 2 in Algebra 2. I'm first going to start by going over Reportable Standard 1, the simplifying standard. So if you look at question 4 with me, this is an example of something we did in simplifying standard. It was to determine if things were equivalent. And we just did that by distributing, adding, subtracting, multiplying. So if we distribute 2 times 3, we get 6n, and the 2 times the 4, we get plus 8, because these two are equal. When you simplify them, as determined, we would say, yes, they are equivalent because they're the same. In sticking with just Reportable Standard 1, I'm going to jump down to problems 7, 8, and 9. Or 7, sorry, through 10. So same thing. These are, again, looking at some different quadratic functions. They're given to you in factored form, and we just want to convert them to an equivalent form. And again, we refer to that as standard form. So all you need to do is just practice your foiling or distributing. So x times x is x squared. X times negative 7 is minus 7x. 5 times x is plus 5x. 5 times negative 7 is minus 35. Combine my like terms, so I have x squared minus 2x minus 35. So equivalent forms. Do the same thing here. When you see two, again, parentheses, you could do those two parentheses first, or you can distribute. If you distribute the 2 only gets distributed to the first parenthesis. So it's just 2x minus 8. The second parenthesis does not change. So just distribute it to one side parentheses. Now you're going to FOIL or distribute again. So you get 2x squared plus 2x minus 8x minus 8. Combine like terms, so you have 2x squared minus 6x minus 8. So again, these are equivalent forms. The next ones, these are written in vertex form that we saw in Chapter 2, and again, they want you to convert them to standard form. So when we were doing this in Chapter 2, again, you had your negative 2. When you saw a quantity that was squared, you needed to remind yourself that it was written twice, and then you had to subtract 5. So just like we were doing up here, the first thing I'm going to do is distribute the negative 2. So I get negative 2x minus 2. I do not change the second parenthesis, and then I subtract 5. Now I have to FOIL, so negative 2x squared minus 2x minus 2x minus 2, and then we have our subtract 5. And now it's just combined like terms. So negative 2x squared minus 4x minus 7. So these two things are equivalent forms. Do the same thing with number 10. So we have our negative sign. We have x minus 6 written twice, and then plus 4. First, distribute your negative 1. So you get negative x plus 6, and then you don't change the second parenthesis, and you still have your plus 4. Distribute or FOIL, so you get negative x squared plus 6x plus 6x minus 36 plus 4, and then combine like terms. So you have a negative x squared plus 12x minus 32. So again, this and this are equivalent forms. The other part of Chapter 2 that we had was all about analyzing graphs, and that's Reportable Standard 3. So I'm going to go back now and do the other questions, questions 5 and 6, related to Standard 3. So questions 5 and 6 are just multiple choice. It says circle the function that matches each graph, explain your reasoning. So this is a parabola opening up. So I'm immediately going to cross out this one because it had a negative sign. So that doesn't work, opening up. The next thing I'm going to notice is I'm going to notice that it crosses at x-intercept at negative 2. It cannot be this equation because that would give me an x-intercept of positive 2, just like this one. So my correct answer is the third one that has a positive a value, an x-intercept at negative 2, and x-intercept at negative 8. Remember, it's always the opposite of those. Working with number 6, same thing. It's opening up, so it cannot be the negative values. And then I look again, I have an x-intercept at negative 2, and the only one that gives me a negative 2 is that second equation. So we were working on our a values, and we were working on our x-intercepts in Chapter 2. Now I'm going to go down to question number 11 with graphing and work on a lot of graphing questions. So in Chapter 2, the other thing that we did was we started to graph quadratics. Things that we talked about when we graphed quadratics was reference tables. And sometimes we didn't like how the book wrote them, so we would write x and y. Sometimes we'd even go from negative 2 all the way to positive 2. Again, all you're doing is, because this is an x squared, you're just squaring these numbers. So negative 2 squared is 4, negative 1 squared is 1, 0 squared, 1 squared, 2 squared. So that's how they came up with those. To find your corresponding points, you have to remember that this is going to shift you to the right 1, and this is going to shift up 3. So what that does to your corresponding points, and I'm just going to draw another t-table, is you're going to add 1 for right 1, and you're going to add 3 to the y values for up 3. So if I add 1 to all these, I have negative 1, 0, 1, 2, and 3. And then if I add 3 to the other values, that's 7, 4, 3, 4, and 7. So to complete my graph, my parent graph just looks like the parabola. My shifted graph is, again, moving to the right 1 and up 3. So if you look at your points, you have a point at negative 1, 7, 0, 4, 1, 3, 2, 4, and 3, 7. And that's my new graph. We're just going to practice a few more of those. Question 12 is kind of the same thing. This 2 means that you have a dilation or a vertical stretch. You're moving to the right 3 and you're moving up 4. So again, your corresponding points, that means, I'm just going to draw the same t-chart down here. I'm going to the right 3, so I'm adding 3 to the x's. The dilation means I'm going to multiply the y's by 2 and then add 4. Again, if you don't like the table from the book, make your own quadratic table. We went from negative 2 to positive 2. And again, if you square those, this was our reference table. So you just had to add 3. Add 3, add 3, add 3, add 3, add 3 to the x's. Then double your y's and add 4. Double your y, so 2, add 4. Add 4, and double them and add 4. So your parabola is going to look stretched. So again, your parent parabola looks something like this. Your transform parabola, again, you have a point at 1, 12 off the graph, 2, 6, 3, 0, 4, 6, 5, 12. Notice that it looks vertically stretched from that dilation and that it's shifted to the right and up. Oops, this should be a 4. That's why it looks funny. 3, 4. 3, 4. I had a point there. So it looks like this. Still vertically stretched and shifted up. Again, we just have a few more videos where we practice the same things. Question 13, sketch the graph and tell whether the transform is a vertical stretch or vertical compression. Anytime that you have a whole number, that's going to be a vertical stretch. Again, we just refer to that as a dilation of 5. Question 14, again from Chapter 2, is about the graphing standard, Standard 3. And this actually relates to the current chapter that we're studying, where it says, write a function using the graph given the points and your calculator. Or regression, we did this back in chapter 2. So the first thing that you want to do is identify what those points are. It looks like I have a point of 1, 1. I have a point of 2, 2, a point of 3, 1, a point of 0, negative 7, and a point of, looks like, 6, negative 7. Actually, I think this point is actually 2, 1, and this point is 3, 2, and this is 4, 1, looking at my scale. Once you've identified the points on your graph, then we can do just like we've been doing this chapter. You go to Stat, you go to Edit, and you're going to type in your points. So again, this point looks like it's 2, 1. So the list 1 would be 2, and its matching value would be 1 in list 2. And then you go back through. The next point over was 3, 2. So this would be 3, enter, and this would be 2, enter. Go over the next point. Looks like it's 4, 1. So 4, enter, 1. The point over here looks like it's 6 and negative 7. And then the last point that I kind of went back to looks like it's 0 and negative 7. If there are other points in your table, just make sure that you delete them. And then once you have all your points in here, again, we know that this looks like a parabola. So if you go to Stat, Calculate, and again, we choose any one of those values. We're going to try quad regression first. And you calculate your equation. And there you have it. And notice that r squared is a perfect one because this is a perfect parabola. So you'd have negative x squared plus 6x minus 7. So negative x squared plus 6x minus 7 is my equation for this. And it's all based on my calculator. The next thing we're going to do is, if you have your review packet, there are just 4 other questions that review this standard in Chapter 2. And they're in the second part of the semester review. So if you flip through your book or through your packet to the second part, we're going to go through at least one of those. It looks like this. So again, very similar to what we were just doing before. It says show your reference table and the transform table. So again, I just like to write what's happening. There's a reflection, the negative sign, there's a dilation of 2. It's moving to the left 3, and if I move my cursor a little bit, I think it's moving up 8. So again, because this is a squared, my reference table is a quadratic, x, y. So I would go from negative 2 to positive 2. Quadratic means you just square this. Negative 2 squared, negative 1 squared, 0 squared, 1 squared, 2 squared. And then my transformed table is move to the left 3, reflect, dilate, and then move up 8. So left 3, I just subtract 3, subtract 3, subtract 3, subtract 3, subtract 3 from these x values. Then I double these. So negative 2 times 4 is negative 8 plus 8. And then I keep going. Negative. And I see that I have this. And then I would sketch my parabola. My transform parabola should make sense that it is upside down. So negative 5. And it's a little stretched out. So that's what my transformed parabola looks like. The rest of the problems are in similar notation. If you have questions on then the others, look at the answer sheet for the solutions or come in and ask for some help. Thank you.